Hello, we are team number 3 and we are going to present our project that is about the conservation of energy focused on spring. But first, what is conservation of energy? As we all know, the law of conservation of energy states that energy cannot be created or destroyed, only converted from one form of energy to another. This means that a system always has the same amount of power before and after an event unless it's added from the outside. There are many types of energy, but in this case, we will focus on mechanical energy. Mechanical energy is the sum of potential energy and kinetic energy in a system. In the springs, mechanical energy is conserved, but any friction effect is considered. If a spring is compressed or stretched, it acquires elastic potential energy. Next, we will talk about the potential and kinetic energy.
Hello, my name is Jorge, and I will give you the definition of kinetic energy and potential energy. Potential energy is a type of mechanical energy that is associated with the relationship between a body and an external or internal field or a system of forces. It is potential energy that is it can be immediately transformed into other forms such as kinetic energy, for example. Potential energy of a system, whatever its origin, represents the energy stored if it's given its configuration or position, and therefore to measure it, uh, its a reference point or configuration must be taken into account. The concept of potential energy is useful for both conservative physical systems. We can say that the potential energy and the kinetic energy of a system constitute the mechanical energy. So we can say that potential energy and kinetic energy is equal to total mechanical energy. This type of energy is studied not only by classical mechanicals but also by relationships mechanicals and quantum physics. Potential energy is classified according to the forces that give rise to it, such as gravitational, elastic, chemical, among others. Uh, we can say that it's all for potential energy. Well, now I will talk about the kinetic energy. Kinetic energy is that energy that a body of a system possesses due to the movement. Physics defines is the amount of works done by all the forces acting on a body with given mass necessary to accelerate it from initial velocity and to another final velocity. Once this speed is reached according to the law of inertia, the amount of accumulated kinetic energy will remain constant, that is it. It will not vary unless another force acts on the body again. Everything existing work of is in it, changing its speed and therefore the kinetic energy. The kinetic energy is often represented by the symbol AC, although the symbols T or K. Uh, Sometimes it's usually expressed in joules. We can say that the kinetic energy is like another type of energy. We can transform into heat and other forms of energy.
I'm Alan Maundry, and I'm going to explain what our experiment consists. And it consists of proving the law of conservation of energy using springs, demonstrating that energy is neither created nor destroyed, but rather transformed. It works in a very simple way. When with placing an object, the spring contracts storing energy, potential energy due to its position. After this, it will release that energy, transforming into potential energy. With this, we can deduce that the energy released can vary depending on the weight and radius of the spring. The materials we used for this project were wooden boards, paint, obviously a spring, and some metal to be able to join it correctly.
The first step of the experiment is get the distance when the spring is over the weight. We have two weights, 5 pounds and 10 pounds. We use three masses, 5 pounds, 10 pounds and 15 pounds. When the spring is without a weight, the distance is close to 12 centimeters. When the spring is without a weight, the distance is 12 centimeters. When the weight is 5 pounds, the distance is close to 11 centimeters. So the final distance is 1 centimeter. When are 10 pounds, the distance is 10 centimeters. Finally, when there are 15 pounds, the distance equals to 9 centimeters. Now we will solve the problem that consists of obtaining the potential energy and the distance that the spring obtains with the weight. We have three different weights in pounds. We will use a conversion factor to transform into kilograms and thus obtain the force applied in the spring. Now that we have the mass in kilograms, we will proceed to calculate the force. We know force equals to mass times acceleration. In this case, acceleration is gravity. With the force, we will calculate the force constant of the spring, which is the same in the three cases, since the spring is the same. This constant can calculate like force over distance. Now, with this data, we can calculate the potential energy of the system. Potential energy can calculate like 1/2 of constant of force times distance at square. The result in the three cases is like that, and the dimension analysis says that the units are joules, since it's energy that we talk. We need an equation to find the height. We will use the equation of conservation of kinetic and potential energy as a base, and we will clear for height. Finally, we will calculate the height at which the weight will rise with the spring force with all the data collected. We were able to obtain the potential energy in each case following the Hooke's law, and thanks to this we were able to obtain the height that theoretically would be obtained.
As a result, we have a little variation in our previous calculus. This was because the conditions of the spring that we predict were different. The most important, the constant of the spring. In our newer results, we contemplate the constant of our real spring that has a height of 0.1 meters and diameter of 0.075 meters. The constant of these springs is 2226.87 newtons over meters. As an extra data, every sprint has a different constant that you can easily calculate by applying a known force and measure the compression. With our sprint, we use three weights with a variation of 5 pounds each. And with this, we measure how much every weight compress our little springs and could get the energy that was stored in there. But our experiment doesn't finish here. We want to know where this energy is released. Is the spring deformed? Does it head or jump? Well, for this, we make a little formula, making a conservation of energy. With these formulas of potential energy and the potential elastic energy formula that you can see previously. So, we could find the height of jump. Resuming our experiment, we saw a relationship between the distance that the spring is compressed and the height of jump. With this, we established that with every centimeter of compression, 5 pounds are being applied, and when we release this force, the spring gonna jump 0.5 centimeters for every centimeter of compression.